Hi everybody, thanks for checking out this video. Today we're going to be working with multi-step equations. These are 8th grade standards for Indiana, but I also do this with my advanced 7th grade classes. Before starting on this lesson, you should already be familiar with the distributive property, simplifying expressions, two-step equations, and equations with variables on both sides. Moving forward with these examples that I'm going to show you for this today, I'm just going to kind of work under the assumption that you already know how to do those things. So if anything in that list does not look familiar to you, I do have videos for each of those, and I would recommend that you definitely check those out before this one. Okay, the number one rule for this lesson, you're going to hear me say this a lot, same side, simplify, opposite sides, opposite operations. Whenever we're talking about sides with equations, think of everything as being split through the equal sign. So you've got a left side, you've got a right side. If you have like terms on the same side of that equal sign, then you just simplify them. Pretend like it's not even part of an equation, combine your like terms, make it simpler, easier to work with, easier to look at, right? If they're on opposite sides, that's when you have to do opposite or inverse operations to start moving things around. Okay, so I'm going to show you quite a few of these, and I've got some word problems thrown in here too. For this first one, I've got a number attached to the outside of parentheses. So here's how I've been showing this in my class. Think of this guy like a mailman, okay? My parentheses, that's the neighborhood where he's got to deliver the mail. So in this neighborhood, I have two houses. Oh goody, it's not writing. This is off to a good start, isn't it? Gonna click around because sometimes that fixes it. Gotta love it. Okay, sorry. Inside, J is one house in this neighborhood, and then -4 is another. He's got to distribute or deliver the mail to each house in the neighborhood. And in math land, distribute means multiply. So this simplifies to 9J minus 36. And then I've still got equals 81. And now it's a two-step equation, like you should have done before. So to get the 9J by itself, I've got to undo or do the inverse, do the opposite of that minus or -36. So to do that, I'm going to add 36 to both sides. I don't know why this is giving me fits with writing today. Sorry. My Chromebook is not happy with me, I guess. So add 36 to both sides. I'm going to go straight down my columns. So on the left, I still have a 9J. Those cancel. On the right, add those together and you get 117. The opposite of multiplying by 9 is dividing by 9. So J equals, 9 would go in there 13 times. And like with any equation, you can always plug that back in place of your J and make sure that it really does come out to equal 81. Make sure it's a true sentence that makes sense. Let's try another. So this one looks a lot bigger, a lot more intimidating and complicated. But like I mentioned before, we're going to separate this into a left side and a right side. Okay. If you have like terms on the same side of the equal sign, then you're going to simplify. Same side simplify, same side do the same operation that it currently shows. So look, on the left, I have 19y and minus 3y. So really on the left side, I have 16y. And then I've still got that plus 4 hanging out. Bring my equal sign down. On the right side, these are on the same side. They're like terms, so I'm just going to simplify. I'm going to do the same operation that I see. I'm going to do 10y minus 2y and rename that 8y. It's like every time I lift my stylus, it wants to stop writing. 8y minus 8. And now we have an equation with variables on both sides. So I don't know if that just showed up for you guys or what happened. But it's like all of a sudden, everything just went totally wonky. Try to reload. That was weird, y'all. That was weird. These past couple of days, we have been having Google issues and internet issues. So this probably wasn't the best choice of days to make a new video. But like we do in a regular school day, we're going to make it work, right? We're just going to go with the flow and we're going to make it work. So I have an equation with variables on both sides. I'm going to subtract the 8y because I don't like dealing with negative numbers. If I have the option to keep them all positive, I like to keep them all positive. So I'm going to subtract the 8y from both sides because I want to keep my teeter-totter balanced. On the left now, 16y minus 8y is 8y. I still have plus 4 equals, on the left, be careful, that has a negative sign. I still have negative 8. So then to get y by itself, I'm going to subtract 4. And that leaves me with 8y equals negative 12. I'm going to divide by 8. And I end up with y equals, I can just reduce that. Negative 12 over 8, reduce them by 4, and you get negative 3 over 2, or negative 1.5. If you really hate leaving them as fractions and you want to rewrite it as negative 1.5, it's fine. Same thing. This one is kind of a combination of the two things that you just saw. So I've got distributive property, or what I call mailman problems, on both sides. So I'm going to distribute on the left. Negative 5 times 3m is negative 15m. My goodness. Hello. Thank you. Okay. Negative 15m. If you're in my classroom, you know I talk to technology all the time. I am convinced it helps. You can't tell me otherwise. Negative 15m and then minus 30 equals, distribute. This would be a negative 12m. And then watch out with those signs. Negative 3 times negative 2, that's a plus 6. Okay, I need to get my m's together. I could add the 12m, but I'm going to add the 15 because looking ahead, I know that'll leave me with a positive. So I'm going to add 15m to both sides. And I didn't draw my line to separate it this time through the equals. You always can, though. Sometimes it's such a simple thing, but it helps to just really illustrate those two, highlight those two separate sides. It helps your eyes to focus a little bit better. On the left, I still have negative 30 equals, on the right, negative 12 and positive 15. That's a positive 3m. And then I have a plus 6. And now it's a two-step equation. I'm going to subtract the 6. And on the left, that gives me negative 36 equals, on the right, I have 3m. I'm going to divide both sides by 3. And I get negative 12 equals m. Let's look at another. You know, I always say to my students when they ask me how many subscribers I have, I always laugh because I'm not in this for the subscribers. I'm not trying to become this professional YouTube math sensation or something. Otherwise, I would probably be freaking out about all these little glitches and issues that keep happening. But I do this to help my students or anybody else who happens to come across this video and need help with this lesson. So thank you for bearing with me with the difficulties. Like I said, I make it work. It's fine. Okay, so on this one, on the left, I need to do the distributive. Negative 7 times k is negative 7k. Negative 7 times 9 is negative 63 equals, on the right, I have distributive on this part, 9k minus 45, and then I still have that minus 14k. So a little tip for you. We talked about same side simplify, same side do the same operation. A lot of times your kind of clue, your giveaway that you're going to need to do that is if you have more than 2 terms on the same side. Because if you're just dealing with equations in one variable, you would have a variable term and maybe a constant term, a number without a variable. So if you have more than those 2 things, chances are something can go together. So on the left, I've still got negative 7k minus 63. On the right, let's put those k's together. 9k minus 14k, that's a negative 5k. And then I have minus 45. So I've got to get my k's together. I can add the 5 or I can add the 7. And kind of thinking ahead, I hate negatives. So I'm going to add the 7 because I know that'll leave me with a positive 2 on the other side. So it cancels on the left and I have negative 63. On the right, negative 5 and positive 7 is positive 2k minus 45. To get rid of the minus 45, I'm going to add 45. So on the left, let's see, that would be a negative 18 equals 2k. Those dropped out. I'm going to divide both sides by 2. The little mark there kind of look like a negative. That's just a 2. And I end up with negative 9 equals k. And I know I said this before. I know a lot of you probably don't like to take any extra time than you have to on problems. But the great thing about equations is you always know before you turn in your homework or your test, whatever it is, if you're right or wrong, if you just plug it in. If you plug it in and what you're left with makes no sense, don't turn in that answer. Redo it. So this one looks crazy gross. And if you're one of my students, you'll always see at least one of these on a homework assignment, quiz, or test. By now, you should be comfortable working with fractions, even though I know those are like total little demon problems in a lot of people's eyes. But this one's not so bad. So for now, I'm going to leave this as 1/2 r. I'm going to distribute. That's really 2 over 1, right? If it helps you to see that. So that becomes a positive 6 over 4r, and then a minus 2 equals 1/4 r plus 6. Okay, so on the left, this one does look messy. So I'm going to help myself out by separating it. On the left, I can put those r's together. 1/2 is the same thing as 2/4. So I'm just going to kind of mark that out and rename that as 2/4. 2/4 plus 6/4 is 8/4 r minus 2. I don't want to get too lost in what I'm doing, so I'm going to go ahead and rewrite all this. That way I don't miss something later. The nice thing about this, though, 8 over 4, that's really just a 2, right? So all those fractions that we were dreading, we just got rid of some of them. So 2r minus 2 equals 1/4 r plus 6. I'm going to subtract 1/4 r. Whoops. So on the left, I'm going to have to go over to the side. I'm writing too big on this one. 2 minus 1/4 is 1 3/4. If you want to go ahead and make them improper, you can. I'm going to do that in a little bit. I'm just going to go ahead and write down that it's 1 3/4 r minus 2. And now on the right, I have a 6. I need to add the 2 to both sides to get rid of that. I'm going to go up here now to the right. So I have 1 3/4 r equals 8. The opposite of multiplying by 1 3/4 is dividing by 1 3/4. So if I do that on both sides, on the left it cancels and I just have my r. That was our goal all along, right? On the right, the new little mini problem that I'm doing is 8 divided by 1 3/4. Now, because 3/4 is a terminating decimal, it's one that stops, it doesn't repeat. If you want to change that to 1.75, you're still going to end up with the same answer. However, I usually encourage my students, especially as we prepare for the state test at the end of the year, if it starts as a fraction, leave it as a fraction. So I'm going to make this 8 over 1 divided by 7 over 4. And then this year, we've been calling the division for fractions. We've been saying we need to make some chicken. KFC instead of KCF. It's way more fun to say KFC, right? Chicken, get it? Yeah. So K is for keep it, 8 over 1. F, flip it, 4 over 7. And then C is for change it to multiply. Multiply across and across, you get 32 over 7. 7 fits into 32 4 times. That would be 28. So you would have 5 leftovers. I know that seemed like a whole lot that went into that problem. But if you go back, rewind this a little bit, rewatch it, kind of break it down step by step. Honestly, what we did wasn't anything that crazy challenging. You can do that. You just may need to go back and look at it one more time. Okay? Okay. Sometimes when you've got these multi-step equations or equations that have variables on both sides, you get these really wackadoodle ones at the end. They're just totally weirdo where the variables disappear. When the variables cancel themselves out, they just drop out completely, then there's 2 possibilities for what that means. Scenario number 1. If you end up with a number equals itself, so you get something that says like 5 equals 5, that's always true, right? That's a statement that makes sense. So when you're left with something that makes sense, your answer is all real numbers. It means you can literally plug in any number for your variable and that equation is going to come out to work. The other scenario is when you're left with something that makes no sense. You're left with something like 3 equals 4. 3 does not equal 4. So when it comes out to be something that makes no sense like that, it's called a null set. The symbol is this 0 with the slash through it. Null means empty. It's an empty set. There's no number that belongs in that solution. There's nothing you can plug in that's going to make that equation work. There's no solution to it. Let me show you one of each of those. So I'm going to start the same way we've been starting because as far as we know right now, everything's all hunky-dory. So I'm going to distribute and get 12x plus 36 equals, distribute over here too. Don't touch this guy yet. He's not part of it. That gives me 8x plus 36. And now I've still got that 4x hanging out. On the left, that's just a 12x plus 36. On the right, 8x and 4x is 12x. And then I have plus 36. Okay, so you can already see that what you have on the left is the same thing as what you have on the right. If you take it one step further and you get your variables together, they drop out over here and leave you with 36. They drop out over here and leave you with 36. So this is like case number 1 that I showed you on the slide before this. I'm left with something equals itself. That's always true. 36 is always going to be the same thing as 36. So because it comes out to be something that's always true, that means I've got an infinite number of possibilities for my answer. So the proper way to write that, unless you're with a different teacher who wants it written differently, it's all real numbers. For me, you can shorten it and say all reals. Any real number can go in for your variable, and that equation is going to work out just fine. Okay, let's try this one. Honestly, the hardest thing about this one is the distributive on the left side. Be careful on ones like this because it's not just a 2 that you're distributing, it's a negative 2. Minus and negative go hand in hand. So this is 10p. And then that becomes negative 6p. And then a plus 12 equals 12p minus 24 minus 8p. Okay, anytime they're big, I always separate them for my students. It just, I don't know, makes it look a little bit less intimidating or something. So on the left, 10p minus 6p, that's 4p plus 12 equals, on the right, 12p minus 8p, that's also 4p minus 24. So I can already tell that my variables match, but the other thing doesn't. If you want to go ahead, get your variables together so you can subtract 4p from each side. I'm left with 12 equals negative 24. That makes no sense whatsoever. 12 is not equal to negative 24. So this is when you have no solution. For my students, if you just want to put the symbol for no solution, that's fine. I would do that, or I would write it out. Just know that on a standardized test, it is possible that you would see that written as the null set. Null means empty. It means there is no number that fits into that solution. Okay, I've got 2 word problems left. So this one says, Mrs. Luger's class is holding a food drive. Okay, pause. Yes, I used my own name. Yes, I used Harry, Ron, and Hermione. Yes, I'm a massive Harry Potter dork, and if I could have my way and teach at Hogwarts, I would. So just, let me have my fun. So Harry collected 10 more cans than Ron. Hermione collected twice as many as Harry. If they collected 130 together, how many did Harry collect? Okay, let's kind of start making a list. So we've got Harry, we've got Ron, and we've got Hermione. It says Harry collected 10 more than Ron. So for Harry, I'm going to do 10 plus, I'm just going to use R for Ron because that's the first kind of unknown that it gives me. And for your variable, you always want to use a lowercase. So I'm going to call that 10 plus R. So that means for Ron, I'm just going to say R. For Hermione, she was twice or 2 times as many as Harry. So I'm going to say 2 times in parentheses Harry's 10 plus R. And then I know altogether it was 130. Altogether means we add. So I'm going to show 10 plus R plus Ron's R plus Hermione's 2 times 10 plus R altogether equaled 130. Then I'm going to start simplifying. I need to do that distributive property. So this, for a minute, is still 10 plus R plus R. That becomes plus 20, and then plus 2R. Still equals 130. Same side, same operation. You just simplify. You put them together. So on the left, I've got a whole bunch of stuff that I can do here. Let's start with the R's. Plus R, plus R, plus 2R. All together, that's 4 R's. And then plus 10 plus 20, that's a positive 30, equals 130. To get the variable by itself, I'm going to subtract 30 from both sides. That leaves me with 4R equals 100. Divide by 4, you're going to find out that R equals 25. Be careful. Before you get too excited and call it done, I found out Ron was 25. But what I wanted to know is how many Harry had. So if I found out Ron was 25, Harry was 10 more than that. So Harry had 35 cans. If you wanted to go ahead and find out what Hermione had, then you could do 2 times Harry's 35, and she had 70. But all I needed to know for the final answer on this one is that Harry had 35. Last one. The school has $2,000 to spend on an end-of-year party at the park. It costs $150 to rent the shelter. How much can be spent per student on food if each of the 225 students is also to receive a $350 gift? Okay, so here's what we know. We have to pay $150 for that shelter so that we have our space to decorate and set up and everything. Plus, there's 225 students, it says right here, and we need to get them food. So that's 225 times whatever the cost of that food is. Plus, we're also getting each student a gift. So that's 225. Oh, it was doing well writing for a while, and then it just decided to stop again. 225 times whatever this $3.50 gift is. And all together, I've got $2,000 to work with. So I'm going to start simplifying. Over here on the left, this is 150 plus 225F plus, if you take 225 times $3.50, you're going to get $700. Ugh, it doesn't like this problem. $787.50. And then my total to work with is $2,000. I see more than two terms on the left, so I know I've got stuff I can put together. This 150 can go with the 787.50. So that 225F is going to hang out for a minute. Put those constants together. That is $937.50. And again, I'm working with 2,000. To get F by itself, I need to start by subtracting that $937.50. So we're getting the gift amount out of there. That way we can put all of our focus on the food amount. So let me see. Let me grab my calculator. My kids can use that. 225F equals, when I subtract, I get $1,062.50. To get F by itself, I'm going to divide by 225. This one comes out to be kind of messy, but with money, you get two decimal places, right? So when I round it to two decimal places, I find out we can spend $4.72 for each student on food. We just can't go over that. We've got 2,000 to work with, so if we spend less than that, it's fine, but $4.72 would be the max. Okay, we covered quite a bit in this video. Hopefully that helped. Hopefully you got your questions answered on multi-step equations. If you need more help with 7th or 8th grade math standards, I do have a bunch of other videos. My YouTube channel is Math with Luger. Feel free to check it out and subscribe. But like I said within the video, I'm not in this for subscribers. Hopefully it helps somebody out there with this lesson. That's what matters to me. If you stuck it out for the whole thing, thank you so much. Until next time, bye.